Good evening, guys. In the last session, we completed our discussion related to blue-green deployment model. Are you guys able to complete that process? I have given the YML files in my Git repository, and I have given the steps also, what we have executed in our yesterday session. Yesterday, two times I have explained how can we deploy our applications by using blue and green deployment model. Anyone not able to practice this one? Guys, anybody not able to practice blue-green deployment model? Anybody faced any issues in that?
No, sir.
So all of you able to practice that blue and green deployment model? Yeah, perfect. Next one. Today, let us talk about a concept called package managers in the Kubernetes. Okay, so let's understand what is package manager. Already in the Linux, we have seen package managers. If you want to install any softwares in the Linux machine, then we are using package managers. Like yum package manager we have seen, yapt package manager we have seen. Okay, so we have discussed already Linux concepts here. In Linux OS, we have package manager concept to install required softwares or packages like yum package manager, yapt package manager we have. So if you are going with Amazon Linux machine, so we have different flavors of the Linux. So when you create a machine by using Amazon Linux, then you will use yum package manager to install software in that machine. Like yum install Java, yum install Git available, yum install Maven. Like that, several softwares we have we can install in the Linux machine by using yum package manager. Similarly, if you go for Ubuntu Linux machine, okay, then we are going to use apt package manager. Amazon Linux available and Ubuntu Linux is available. In the Amazon Linux machine, yum package manager we will use. In the Ubuntu Linux machine, yapt package manager we are going to use. Okay. So I hope you are able to recall whatever we discussed in the uh, Linux classes regarding package managers. In the Linux OS, we have package manager concept to install required software or packages. So yum app package managers available. Amazon Linux will use yum as a package manager. Ubuntu Linux will use yapt as a package manager. Okay. So why we are talking about these package managers in the Kubernetes. Okay. So some of the Kubernetes resources we need to discuss. Daemon set, stateful set, those concepts we have to discuss, right? So to discuss those concepts, we need to know package manager concept in the Kubernetes. Okay. So in the Kubernetes, there is a concept called Helm concept is available. So what is Helm in the Kubernetes? What is Helm in the Kubernetes? So Helm is a package manager which is used to install some softwares in the Kubernetes cluster. So Helm is a package manager which is used to install required softwares in the Kubernetes cluster. How we have yum package manager, yapt package manager to install softwares in the Linux operating system. Similarly, I want to install some softwares in the Kubernetes cluster. So to install softwares in the Kubernetes cluster, there is a package manager available, which is called Helm. So Kubernetes, Helm charts concept is available. What is a Helm in the Kubernetes? Helm is a package manager which is used to install required softwares in the Kubernetes cluster. So what is the meaning of this Helm? Helm will use charts concept to install required packages. So there is a concept called Helm charts concept is available. So Helm charts concept is available. What is the purpose of the Helm charts concept? What is the purpose of this Helm charts concept? Helm charts are used to install required packages in the Kubernetes cluster. So for example, in the Kubernetes cluster, I want to install, in the Kubernetes cluster, I want to install a software called, I want to install a software called Grafana. Okay, for monitoring for the for resources monitoring, we are using Grafana. And for collecting the metrics of our cluster, I want to install Prometheus. I want to install some ELK stack to monitor logs of the application. So in the Kubernetes cluster, we are deploying our applications. We need to monitor the application logs. We need to monitor our cluster. So in order to do that, we are going to install Grafana, Prometheus, ELK softwares in the Kubernetes cluster. So instead of we are installing these softwares manually in the cluster, we can take the help of Helm chart. So what is the Helm chart? Helm is the package manager which is used to install required softwares in the Kubernetes cluster. Helm is a package manager which is used to install required softwares in the Kubernetes cluster. Okay, now, so why we are talking about this Helm charts? So in the Kubernetes cluster, I want to install some softwares like Grafana, Prometheus, ELK softwares I have to install. They are used to monitor the resources in the Kubernetes cluster. So Grafana pods we need to create, Prometheus pods we need to create, ELK pods we need to create. Okay, so those pods, instead of we are creating by using YML files, we can deploy them by using Helm chart. So first we need to install Helm in the Kubernetes cluster. Once a Helm is deployed, by using Helm we can deploy the remaining softwares that are required for our application. Are you guys able to understand what is Helm in the Kubernetes, guys? Are you guys able to understand what is the Helm in the Kubernetes?
Yes, sir.
What is the Helm in the Kubernetes?
Helm is a package manager which is used to download the required softwares for Kubernetes clusters, sir.
Right. So Helm is a software which is used to install required softwares in the Kubernetes cluster. Suppose in my cluster, I want to monitor the resources. Okay. To monitor the resources, Grafana, such kind of softwares are required. So instead of we are going to install those softwares manually, we can take the help of Helm charts and we can install the required software by using Helm charts. Okay. So what is Helm in the Kubernetes? Let's see here. Helm is a package manager for the Kubernetes application. How we have the package manager for the Linux? Similarly, for the Kubernetes cluster, we have the package manager, that is the Helm. Helm is going to allow you to install or deploy applications on the cluster in the similar manner how we have the M app for the Linux distribution. So Helm manages Kubernetes resource packages through charts. So chart, so if you want to install any software, then Helm chart we are going to execute. What is the meaning of a Helm chart? What is the meaning of Helm chart? Helm chart is nothing but set of configuration files. So what are the manifest YMLs we are executing? Pod manifest YML, namespace manifest YML, pod manifest YML, service manifest YML, several manifest YMLs we are creating and we are executing. So if you organize all those manifest YMLs in one directory for execution, that is called Helm chart. So here you don't need to write those YML files to deploy some softwares in the cluster. To install some softwares in the cluster, you don't need to write those YMLs. Already, Helm is providing the charts for them. Chart is nothing but set of configuration files we are having to install a particular software. Suppose I want to install Grafana. Then I will download the Helm chart of Grafana and I will execute it. Then Grafana software will be installed in the cluster. Using that Grafana, I can monitor the resources of the cluster. I want to install Prometheus in the cluster. So instead of writing a YML configuration YML to install a Prometheus, I will download the Helm chart for the Prometheus and I will execute that Helm chart. Then Prometheus software will be installed in the cluster. So Helm is a package manager which is used to manage the software's installation in the cluster. it will manage that installation by using chart concept, Helm chart. What is the meaning of a Helm chart? Helm chart is nothing but collection of files which are organized in the particular directory. Okay, so the configuration information related to chart is managed in the configuration folder. So there will be a release file will be available, which is used to execute that Helm chart, which is used to execute the Helm chart concept. So what is the Helm architecture? So here, Helm will maintain one chart repository. All the Helm charts will be available in the chart repository. There are thousands of Helm charts available. Okay, so to deploy several software, several charts available in the chart repository. So what we are going to do is, in our Kubernetes cluster, we are going to install Helm client software. So in our EKS host VM, we are going to install Helm client software. That the Helm client, we are going to install the Helm client software. That the Helm client software is connected with the Kubernetes API server. Okay, API server we have whenever we send a request, when we execute any YML file by using kubectl, then that API server is going to take care of that request and it will store that in the etcd. Then scheduler will come into picture. All the process is going to happen in the Kubernetes cluster. So here, Helm chart repository will be available. All the Helm charts are stored in that. All the Helm charts are stored in that. Okay, guys. All the Helm charts are stored in that machine. So we are going to execute the Helm client command. We are going to execute the Helm client command. Then Helm client command, Helm client software will communicate with the chat repository and will download the chat and will give to the Kubernetes API server for execution. So what is the concept here is, earlier we created the pods, services and all by writing our own YML files. Now we will use predefined YML files by using Helm chart. Helm chart is nothing but set of configuration files only. Helm charts are nothing but set of configuration files only. So what we need to do in our Kubernetes cluster, we need to install Helm client and we will download the Helm charts and we will execute the Helm charts. Then required softwares will be installed. Required softwares will be installed. So what kind of Helm charts we are going to use, guys? So in the Kubernetes, I want to install a software called Prometheus. In the Kubernetes, I want to install a software called Prometheus software. What is this Prometheus software in the Kubernetes? Prometheus is an open source system monitoring and alerting toolkit. That means in my Kubernetes cluster, lot of pods are created, lot of services are created. Okay, deployment will be created. Okay, so replica sets will be created. So many resources we are creating in the Kubernetes cluster. Now, I want to monitor how the cluster is working, how the resources are working in the Kubernetes cluster. So to do that kind of a monitoring in the Kubernetes cluster, we are going to use Prometheus concept. Prometheus is an open source system monitoring and alerting tool. So what is the purpose of this? This Prometheus software we will install in the cluster by using Helm chart. Then this Prometheus software will collect the metrics as a time series data. Nothing but continuously Prometheus software will collect the data from the cluster and will give the data. Okay. So if you want to do some monitoring, so then Prometheus we are going to install. This Prometheus software will collect the data from the cluster on time series, nothing but for every 5 minutes, for every 10 minutes, it is going to collect the data from the Kubernetes cluster and it is going to provide that data. So once the data is collected by the Prometheus, then we need to display that data in some graphical form. So to display the cluster data, whenever you are monitoring the cluster, to display the cluster data in the graphical format, we are going to use a software called Grafana software. So what is the purpose of this Grafana software? Grafana is an analysis and monitoring tool. So Prometheus, Grafana, combination we are going to use for monitoring the resources in the Kubernetes. Prometheus will collect the data from the cluster and will give the data to the Grafana. Then Grafana will display the data in the graphical format. Okay, so it is used to collect the data from the Prometheus, and it will display some graphs when you are monitoring the resources. So Grafana is an analysis and monitoring tool. Grafana is a multi-platform, open source, analytical, and interactive for interactive visualization will provide for our application. This Grafana will provide the charts, graphs, and alerts for the web when connected to supported data sources. So Grafana will connect with the Prometheus for the data source. That means in the cluster, we are going to install Prometheus software and we are going to install Grafana software. Prometheus software will collect the data from the cluster and will give to Grafana. Then Grafana is going to display the data in some chart format, in some graphs format. So basically, what kind of monitoring we are going to do with the Grafana and Prometheus? Okay. So for this first, let's see the Prometheus architecture. In the Kubernetes cluster, we are going to install the Prometheus by using Helm chart. Then the Prometheus server will connected to the Kubernetes resources and it is going to take the data from the Kubernetes resources and will give the data to the Grafana software. Then what this Grafana software will do? Data visualization. So whatever the data collected by the Prometheus will be given to the Grafana. Grafana is going to display that data like this in the graphical format. That means what is the memory of our nodes available in the cluster? What is the CPU utilization of our cluster resources? Okay. So how many worker nodes are available? How many namespaces are available, how many pods are running, how many services are running, how much memory utilized, how much memory consumed, all such kind of data we can monitor by using this Grafana. So Grafana software will provide you, Grafana software will provide you this kind of visualization for Grafana will provide you this kind of visualization for you. But who is giving this data for the Grafana? This data will be given by Prometheus. Grafana and Prometheus we are going to install in the Kubernetes cluster. There are two ways to install Grafana and Prometheus in the Kubernetes cluster. One is you write the YML files and you deploy the Grafana pods and Prometheus pods. Another one is you take the Helm chart for the Grafana and Prometheus and you execute the Helm chart. Which one is easy, guys? Writing the manifest YMLs and executing them is easy, or executing the Helm chart is easy. Writing the manifest files on our own and execute them to deploy the Prometheus and Grafana is easy. Using Helm chart is easy. Installing the softwares on our own is easy, or Helm chart is easy. Helm chart is easy. Why the Helm chart is easy? Why the Helm chart is easy? Come on, guys. Why the Helm chart is easy? Why the Helm chart is easy? When you go for the Helm chart, do we need to write our own YML files, or we no need to write our own YML files? Do we need to write our own YML files, or we don't need to write our own YML files when you go for the Helm chart? Ready-made softwares will be available when you go for this. Ready-made softwares will be available when you go for this. Okay. So Helm charts we are going to use to install required softwares in the cluster. Helm charts are nothing but package managers for the Kubernetes cluster. Helm chart is nothing but Helm is a package manager. In the Helm repository, lot of charts available. Those charts are used to install the required softwares in the Kubernetes cluster. So one of the examples that we discussed for the Helm charts, Prometheus and Grafana softwares will be available. Those softwares we are going to be installed by using Prometheus, and those softwares we are going to install by using this Kubernetes Helm charts concept. So you got the idea what is Helm in the Kubernetes? You got the idea what is Helm in the Kubernetes and where we will use Helm in the Kubernetes? Yes, Helm is a package manager. As we discussed, Helm is a package manager for the Kubernetes. It is used to install required softwares in the Kubernetes cluster. In the Helm, there are several charts available. What is a chart in the Helm? Chart is nothing but collection of configuration files, collection of manifest YML files available. The organized YML files is called one chart. One chart is used to install one software. To install one software, set of configuration files are required. Instead of we are writing them, we will download the Helm chart and we are going to execute that Helm chart. We are going to download the Helm chart and we are going to execute that Helm chart. Are you guys clear with my point? Good. Helm architecture, can you see this, guys? Chart repository. In the chart repository, lot of charts will be available. In the chart repository, lot of charts will be available. Then Helm we are going to install in the cluster. Helm we will install in the cluster. Okay. Then when we download the chart from the Helm client and we will execute it by using Kubernetes API server, we will send the request to the API server. API server will take care of that. Good. Now let us look at this. What is Prometheus in the Kubernetes? Prometheus is an open source system monitoring and alerting toolkit. Prometheus collects and stores its metrics as a time series data. So whatever the metrics are available in the cluster, that means when the cluster is running, the resources are executing in the cluster, right? The resources are executing in the cluster. Those resources we are going to collect by using Prometheus and will give to Grafana. So what is Grafana? Grafana is a monitoring tool. Grafana is a monitoring tool. Whatever the data it has collected by the Prometheus, that data we are going to use in the Grafana and we are going to display some graphs by using this. We are going to display some graphs by using Grafana. So Grafana and Prometheus architecture you can see here. Grafana and Prometheus architecture you can see here. Look at that architecture, guys. Yep. Next one. This is the dashboard that we are going to get. This is the dashboard we are going to get using Grafana. This is the dashboard we are going to get by using Grafana. Are you clear? Yes, good. So I hope you got what is Helm and what is Grafana and what is Prometheus. So theoretically we are discussing, we will do the practicals also for these all concepts. Okay. Next one. In the Kubernetes, there is another software available which is EFK. We are going to install EFK in the Kubernetes cluster. So what is this EFK in the Kubernetes cluster? Let us try to understand. So guys, here EFK is the combination of three products, guys. E stands for Elasticsearch, F stands for FluentD, okay, and K stands for Kibana. E stands for Elasticsearch, F stands for FluentD, and K stands for Kibana. So we are going to use this EFK stack in the Kubernetes cluster. Let us look at this one. EFK stack set up in the EKS cluster. Okay, we are using EKS cluster to run our Kubernetes. So in the Kubernetes, we are going to set up EFK. So first let's understand what is that EFK. First let's understand what is that EFK. So EFK stack is collection of 3 open source products, guys. So E stands for Elasticsearch, F stands for Fluentd, and K stands for Kibana. So what is this EFK stack is going to provide? So it is used to collect the logs of our application. Inside the Kubernetes cluster, we can run several applications. Inside the Kubernetes cluster, we can run several applications. Okay, so front-end application, back-end application like this. We can run several applications in the Kubernetes cluster. So when you run several applications in the Kubernetes cluster, how do you monitor those applications? How do you monitor those applications? If some problem occurs in the application, then how you will identify the problem? How do you troubleshoot the problem in the application? How do you troubleshoot the problem in the application? That's where log monitoring comes into picture. That's where log monitoring comes into picture, guys. Log monitoring comes into picture. So when we are going for this log monitoring, how we are going to implement log monitoring in the Kubernetes cluster? How we are going to implement log monitoring in the Kubernetes cluster? So to do the log monitoring, we are going to take the help of this EFK stack. E stands for Elasticsearch, okay? F stands for Fluentd, K stands for Kibana. Using this Elasticsearch, we are going to store the logs, okay? So Elasticsearch is called as a log lake. Log lake nothing but where we are going to store all the logs of our application, okay? Multiple applications are running in the Kubernetes cluster. So for that application, all the logs we are going to collect, all the logs we are going to store into one location that is called as Elasticsearch. The next one is Fluentd. So what is the meaning of Fluentd? Fluentd is used for shipping, processing, and storing the logs. Fluentd is used for shipping, processing, and storing the logs. Then Kibana. Kibana is also a visualization tool to monitor the logs. So EFK stack. EFK stack is the combination of 3 open source products. One is Elasticsearch. Second one is Fluentd. Third one is Kibana. Elasticsearch, Fluentd, and Kibana. Good. Now let us see the EFK stack architecture in the Kubernetes cluster. Let us see EFK stack architecture in the Kubernetes cluster. Guys, all of you, could you please observe this diagram? Could you please observe this diagram? Come on, guys. Are you able to understand what is this EFK stack in the Kubernetes cluster? So in the cluster, multiple applications will be deployed. So let's consider them as microservices. So we are considering them as microservices. So we are going to deploy multiple microservices in the Kubernetes cluster. Okay. So for every microservice, log file will be available in order to monitor the logs. By using kubectl logs command with the pod name, you can monitor the logs of your application. But if you have 20 pods, can we monitor the 20 pods logs individually by using kubectl logs command? Is it easy to monitor the logs of your pods manually by using kubectl logs command, guys? Is it easy to monitor the logs of the plot separately by using kubectl logs command? By using kubectl logs command also, we can monitor the logs. But if you have one pod, then you can monitor by using kubectl logs command. Suppose if you have multiple pods, then how do you monitor logs of all those pods? So if you have multiple pods, then how do you monitor logs of those pods? If you have just one pod or two pods, then you can monitor the logs of. But if you are having multiple pods, then is it easy to monitor those logs? No. So that's where we need to implement log centralization. That's where we need to implement a concept called log centralization. Okay. So what is the meaning of this log centralization concept? What is the meaning of this log centralization concept? Log centralization concept is nothing but all the pods, all the microservices, logs we are going to collect and we are going to store into one place. Okay. So in multiple worker nodes available in the cluster, multiple worker nodes available in the cluster. So we need to collect the logs from multiple worker nodes. Multiple worker nodes available in the cluster, and we need to collect the logs from those worker nodes. We need to collect the logs from those worker nodes. So when you are collecting logs from those worker nodes, when you are collecting the logs from those worker nodes, so then we will store them into Elasticsearch. So to collect the logs from the worker nodes, here FluentD software will be available. So in the Kubernetes cluster, we need to install FluentD software. So what is the responsibility of this FluentD software? This FluentD software will collect the logs from all the worker nodes that we have in the cluster. Okay, FluentD software will be available, which is going to collect the logs from all the microservices available in the cluster. Then this FluentD software will give the logs to Elasticsearch. So FluentD will read the logs from the cluster. I mean, it will read the logs from all the worker nodes, all the pods. So several pods will be running. All the pod logs we are going to collect, all the pod logs we are going to collect by using FluentD and will store into Elasticsearch. So what is the Elasticsearch here? Elasticsearch is like a log lake where all the pod logs will be stored. Okay. So FluentD is a software which will read the logs from all the pods and will store into Elasticsearch. So what is that Elasticsearch? Elasticsearch is a log lake where all the logs will be stored. Elasticsearch is a log lake where all the logs will be stored. Are you getting my point? Elasticsearch is a log lake where all the logs will be stored. Then what is Grafana? What are the logs are stored in the Elasticsearch? We need to display those logs with the user interface. That's where we are going to use a software called Kibana. Kibana software will provide the UI to set the logs. In the industry, some companies will go with this EFK stack to centralize the log monitoring of our applications. In some companies, they will use Splunk software also to monitor the logs of the application. So Splunk is a commercial software, whereas EFK is open source software. So some companies will use Splunk for the log monitoring. Some companies will use EFK for the logs monitoring. Are you guys able to follow me? Are you able to understand the diagram? Guys, are you able to understand the diagram? What is fluidity? What is Elasticsearch? And what is Kibana? Splunk and EFK, so both are used for same purpose. Both are used for same purpose. The only thing is in the Splunk, more advanced graphs we can generate when we are monitoring the logs because it is a paid software. It is a paid software. And EFK is open source, so less support will be available. Less features will be available when you go for open source software. When you go for paid software, more advanced concepts will be available. When you go for paid software, more advanced concepts will be available. So that's why Splunk is commercial, more advanced concepts will be available in the Splunk when you are doing the log monitoring. So EFK is open source, so less support will be available. So in our application, in the cluster, multiple applications will be available. So in the Kubernetes cluster, multiple applications will be available, right? So multiple pods will be available. Checking the logs of all the pods, checking the logs of all the pods is very difficult. That's why we need to centralize all the pods logs. So to centralize all the pods logs, we are going to use EFK. FluentD software will be available. That FluentD will collect the logs from all the pods running in the cluster and will give that FluentD to the Elasticsearch. FluentD will collect the logs and will give the logs to the Elasticsearch. Okay. Then what the Elasticsearch will do? It will index the logs. So it will store the logs and will index the logs. So what are the logs it has indexed? We can get those logs. We can get those logs by using Kibana. Kibana is going to provide basically a user interface to get the logs. Okay. So Kibana dashboard. So you can see the Kibana dashboard will be available. So when you want to monitor the logs, the Kibana dashboard will be available. That Kibana dashboard we are going to get like this. Kibana dashboard will be available. That Kibana dashboard we are going to get like this. Okay. So you can have a filter. You can set the last 15 minutes logs, last 1 hour logs. So that my application is running in the cluster. There is some issue with the application. I want to get the logs of the application. So in order to get such kind of logs of the application, we are going to see the dashboard, Kibana dashboard, and you can select the dates, you can select the time, and you can refresh, and you can get that Kibana dashboard. So application will be executing in the cluster. Application logs will be available. The logs will be stored into the log file. Those logs we can get by using Fluentd and store in the Elasticsearch. Elasticsearch is used to index all the logs. Then Kibana will provide a user interface in order to monitor those logs. Okay. Now, so how we are going to deploy that Fluentd, Kibana, and Elasticsearch? Okay, here in the Kubernetes we have the resources, right? What are the resources available? We have already seen deployment. Now, stateful set, daemon set. These two resources we have not discussed as of. This stateful set and daemon set we have not discussed as of. Fluentd software we are going to install in the cluster by using daemon set concept. Fluentd software we are going to install in the cluster by using Fluentd. So Fluentd we will be installing by using daemon set. What is a daemon set? We have not discussed as of. We will discuss on that. And Elasticsearch we are going to install by using stateful set concept. What is stateful set that we have not discussed? Kibana. Kibana will provide the user interface to get the logs. Kibana pods we are going to deploy by using Kubernetes deployment. So deployment, stateful set, daemons. Fluentd will be installed using daemons, and Elasticsearch will be installed by using stateful set. Kibana will be installed in the cluster by using deployment. Okay. So these are the three types of Kubernetes resources we are going to use to set up EFK stack in the Kubernetes cluster. So what is the purpose of this EFK stack in the Kubernetes cluster? This EFK stack is used to monitor the resources of the Kubernetes. That means basically we are going to check the logs, log monitoring we are going to do by using this EFK stack. So when we deploy our application in the cluster, when we deploy our application in the cluster, we need to check the logs of the application. Our application will be running in multiple pods. Okay. So checking the each and every pod log is very difficult. Checking each and every pod log is very difficult. So that's why we will install the Fluentd to collect the logs from the pods and store into Elasticsearch. Elasticsearch is going to index those logs. Then Kibana web application will be available. Kibana will provide a web dashboard. Using the Kibana web dashboard, you can get the logs from the Elasticsearch and we can see those logs. And we can see those logs. Are you able to follow me? Are you guys able to follow me? So today, lot of new concepts we introduced. Theoretically, we understood these concepts, guys. Now, practically, we need to work on these concepts. We discussed about Helm charts. We discussed about Helm chart. So what is that Helm chart? Helm is a package manager that we are using for our Kubernetes cluster. Helm is a package manager that we are using for our Kubernetes cluster. So by using Helm, we can install the required softwares easily in the cluster without writing manifest YMLs. We can install the softwares in the cluster by using Helm chart concept. Okay, Helm repository will be available. By using the Helm repository, we can install all the required softwares in the cluster. Okay, good. So Prometheus and Grafana we are going to use here. So Prometheus is basically used to collect the metrics from the cluster and give it to the Grafana. Prometheus will collect the data and will give it to the Grafana. And what Grafana is going to do? Grafana is used to monitor that and we display that in the visualization form. Okay. So Helm charts we are going to use to install the required softwares. Grafana, Prometheus are used to monitor the cluster resources. And in the cluster, application will be executing and we need to monitor the logs of the application. So in order to monitor the logs of the application, we are going to set up this EFK stack in the Kubernetes cluster. We are going to set up EFK stack in the Kubernetes cluster. Okay, so fine. So theoretically, we understood this concept. So anybody having any questions as of now? Can you unmute your mic and ask me?
Sir, you told like using LAM, we can install the softwares. So
Correct.
we have the Jenkins, we have the Ansible
Sir,
also installing softwares.
No.
Like
Jenkins please let me complete. Software's installation, that is different story. Installing the softwares in the Kubernetes cluster is different story. You will not install Jenkins in the Kubernetes cluster, right? Jenkins is a separate server which is used for CAC. So when I say package manager, what are the softwares that are required within the cluster? We are going to install by using Helm charts. So Jenkins will not be installed in the cluster. Jenkins will be outside of the cluster. Are you getting my point?
So you mean to say we can install JDK Git using this LM?
No, man.
That is also inside cluster, no? We will use.
No. That is outside the cluster, right? Inside the cluster, basically this Prometheus, Grafana, EFK, mainly these three softwares we install in the cluster. Not the Git, Jenkins, Maven. These softwares we don't install in the cluster.
In real time, okay. In real time also, which kind of software we need to use for using LM?
These three only. Prometheus, Grafana, EFK.
Like monitoring tools.
Yes, basically monitoring tools we are going to install by using.
In the Splunk also these three are there, sir?
Splunk is a paid software, sir.
No, in the Splunk also only these three. Kibana,
like replacement of these three, that's Splunk, huh, sir?
Replacement of these three is a Splunk. In the Splunk, we will not have Kibana Elasticsearch. The Splunk will have different architecture.
Okay.
Hello, sir. Sir, in the cluster, many application is deployed, right? So
Yes.
if there is an exception occurred in particular application, how can we search using this Elasticsearch or in the log, basically? How can we query the log and
yes, sir. So in the practicals, we will see how to query the logs. Index patterns we are going to create based on the index patterns we are going to create.
Because in the Splunk, we have Splunk query language, right? So
yeah, in the Kibana also, Kibana query language will be available. How do you write the Splunk query? In the same way, we will write the Kibana queries.
Okay.
And so this Elasticsearch, how it will store these logs? Like in which DB we need to create the DB or how?
No, sir. Elasticsearch itself will use its internal database. You don't need to set up any database. Elasticsearch is a software, right? That software will maintain its own database to store the logs.
Sir, we cannot store in S3 the logs, these logs.
Not required, sir. Not required.
If suppose I want to search 2 days before logs and that things I want to do, we can do
yes,
from
in the Kibana. Yeah, in the Kibana, a beautiful dashboard will be available. So you can set the logs based on the time. You can set the logs based on the date also.
Okay, sir. But
Kibana
we can do we can do from S3 for storing the log from
you can if your project having such kind of requirement to store the logs in the S3, then definitely we can do it.
And sir, if we want to delete some logs, then how we will do?
So generally we don't delete the logs, man. What is the purpose of logs? Logs are used for tracking purpose. If you want to delete the logs, the log file you have to delete. RM command.
It will increase our memory size, right?
No problem, sir. Generally logs backup will be available. We don't delete the logs.
One question, sir.
When we install, if you want to delete the logs, that means you need to delete the log file of your application.
Sir, when we install this software using the Helm and all, so this Fluent Bit and all, do these get automatically installed on? I mean, to the place where we want them to, like in this case, some particular microservice and all, or we have to configure it like that?
No, sir. It will be installed in all the worker groups. Whenever we install the FreeND will be installed in all the worker groups.
No, sir.
Yes,
coding.
Sir, I have a question. Sir, the logs will be generated as per the worker nodes or for the containers or for the bots. How would it be, sir?
Sir, generally pods will be generated in the, the logs will be generated by the application. Application is running in the container is running in the pod. So basically it is called as pod logs.
Okay, for each pod there will be one microservices or one.
Yeah, one microservice can have multiple pods also. Basically, we need to consider when I am running my application will be running inside the pod, right? So the logs will be available inside the pod. We are calling them as pod logs. Multiple pods will be available. In multiple pods, logs will be available. We need to collect them and we need to store all the logs at one place. That's where Fluentd will collect the logs from all the pods and will store in the Elasticsearch.
We can go for each pod log as we want.
Yeah, you can check for that, right? kubectl logs pod name, you can get the single pod logs also. But monitoring the single pod log, multiple log pods manually is difficult. That's why this concept is used to centralize the logging of our application.
So the process in Grafana is.
Sorry guys, can you come again?
Yes, one sensor. This is Grafana. Grafana collects data from Prometheus. Right.
Yes, correct.
Yeah, and Prometheus is a server that collects metrics from objects. Right.
Correct. It will collect the metrics from the Kubernetes resource.
So how do we, it is different from metric server, like we use in our variable file, metric server so use.
Sir, metric server will collect limited data. Prometheus will collect different kinds of data from the different types of resources available in the cluster. Metric server will just tell you the CPU utilization, memory utilization, will not collect the remaining details. But Prometheus will collect all the information related to all the resources available in the cluster.
So we only use Prometheus and Grafana for the Kubernetes, or some other applications also use those software, sir?
Sir, Prometheus Grafana can be used for any application monitoring, especially in the Kubernetes, they are used for monitoring the cluster resources.
Oh, those are the monitoring tools, and they can be used by any other applications too,
yes,
right? Not only for. Today, I feel like it's too much information for me. It's a lot of information at one class. That's why I was like, I was having the concept like, oh, Prometheus and Grafana is like sub applications for Kubernetes.
These are just monitoring. Prometheus Grafana is just monitoring.
And also we have a lot other.
Yeah.
So what is the difference between Sumo Logic and EKS, that Elastic Kuber that one?
Sumo Logic, I don't know that, sir. First time I am hearing that. EFK is basically for log monitoring.
So what is the difference between ELK and EFK?
Sir, EFK and ELK, the difference is the middle character. In the EFK, we are using Fluentd. In the ELK, instead of Fluentd, log stash will be available. Fluentd is more advanced when compared with the log stash. Some people will go with ELK, some people will go with the EFK. Elasticsearch Kibana is common. The middle software Fluentd. Here we are using Fluentd. Some people will use a log stash. You can just Google Fluentd versus log stash. Fluentd is more advanced than log stash.
Okay. So for this Fluentd, we need to write any code in our microservices?
No, not required. Just logging. So the developers will implement the logging to get the logs. So just as a DevOps engineer, we just need to configure these three.
Sir, one question. This Elasticsearch and Kibana will also be available on the cluster itself only then, or it will be away from that?
We need to install them as a Elasticsearch, Kibana, Fluentd. These three softwares will deploy in the cluster as a pod. How we are deploying our application as a pod? These softwares also will deploy as a pods in the cluster.
So if we delete the cluster, these software also will delete, right?
Yes, will be deleted. These will be installed in the pods only. These are softwares that we are going to deploy in the cluster as a pods. How our application is deploying as a pod? Similarly, these three softwares also will be deployed as a pods in the cluster. By using those three softwares, we can centralize the logging of the application.
These softwares are interlinked?
Metric software is yes, if you want you can install that also. When you have Prometheus, Grafana, it's not.
No, sir. These three softwares are interlinked.
Yes, sir. If you see the diagram, then there is a relation, right?
Okay, sir.
Sir, in my code,
Fluentd will take the logs and will give to Elasticsearch. Okay, Elasticsearch will give the logs to Kibana. These three softwares are interlinked.
Sir, our user interface are started with the microservice only.
Sir, that application user interface is different. Kibana user interface is different. Kibana user interface to monitor the logs. Application user interface, that is UI application, that is Adiveru Idiveru.
Okay, sir. Okay, sir.
Sir, in my code, like I am using SLF4j or log4j for this logging, and I am using file-based logs, right? I am
Yes.
saving this in file. So for that file, how it will be communicate in this Fluentd?
So Fluentd will take the data from the file, sir. You no need to do it.
For that, we need to configure anything in our code.
No, none. You no need to do anything.
Sir, EFK is applicable for server logs or application logs?
Application logs.
The Fluentd will be deployed as a daemon set or as a deployment only?
Fluentd will be deployed as a daemon set, guys.
Daemon set only. Each node will be having the Fluentd.
Yeah.
Yes, sir.
And sir, earlier you showed one diagram like connected to Elasticsearch, there was this persistent volume claim. So, are we storing that in the database somewhere?
Which one, sir? Can you come again?
Earlier you showed one diagram, right? Same diagram, just the Elasticsearch has some persistent volume.
Yes,
claim.
sir. For storage purpose, values we are going to configure.
Okay. Okay.
Hello, sir.
Yeah, hi.
Yes, sir. Can we use Prometheus metrics for the HPA?
Prometheus metrics for HP. Yeah, you can use it. Or generally, it will take from the metrics, sir. You can use that.
Okay, sir.
Okay, fine, guys. Good. So theoretically, we understand.
Hello, sir.
Yeah.
Sir, in next class, can you explain like affinity and anti-affinity rules in Kubernetes?
All the topics will be covered. So this is not the last class. What are the topics are pending?
Yeah. That just I'm told you like that is like explain. Yeah, sure,
sir. Definitely. Okay, and guys, I want to give you one task for tomorrow. Can you guys do one task before coming to tomorrow's session? Okay, I will give you one video. In that video, I have explained how to set up this EFK stack in the cluster to monitor the logs of the application. Can you try that on your own before coming to the next session? Theoretically, you understood what is this EFK and all. So can you guys do the practice of this EFK stack by referring the video? I have already recorded that and uploaded in our channel. So I would just want to see how many of you can do it on your own. Okay, if you are not able to do it, no problem. I will explain in the class. But just I want to give the chance for you first. Let's give you a try.
Using Helm chart.
Sir, tomorrow what time class?
Without Helm chart, sir, it is directly with manifest YML. I have deployed the TFK stack. Okay.
Sir, tomorrow class timing?
Tomorrow we don't have class, sir. People are asking for a break to do the practice. We have next class.
Yeah, sure. That is okay.
Thank you, sir.
Yeah, guys. So here, 1 year back, I have uploaded one video in the YouTube channel. That is EFK setup in the Kubernetes cluster for the logs monitoring. So 20 minutes video is available. In this video, I have explained how to monitor the logs of our application by using EFK stack. So can you guys go through this video and can you try doing that setup? Can you guys go through this video and can you try setting up the EFK stack to monitor the logs of the application? In that video, I have used manifest YMLs only in order to deploy the EFK stack. The manifest YML is already there in the Git repository. Git repository link also I have shared. Okay, I want you people to give it a try before coming to next session that we have on Monday.
Okay, sir.
Okay,
Good,
sir.
guys. Yeah, thank you guys. Thank you. We'll see you on-
Yeah, sir. Actually, I have one question.
Yeah.
I joined your JRTP class, like a demo session. So I found there are lot many concepts which is belonging to our DevOps class, right, sir? The module 2.